Hello, class of 2020, 4th grade, La Bel Air. This is Mr. Avan again. It is March 28th, and here we are, getting ready to do some more videos on fractions. But before that, as you can tell, all around me, you notice anything? Anything different? Yeah, it's Wa's birthday. Happy birthday, Wa. You are the fool who doesn't like school. Wait a minute. You like school, but you're not a fool. I'm sorry about that. Happy birthday, Wa. I'm sure you're having a good time at home with some new computer games or something. So happy for you. You must be, what, 10 years old now? What? Congratulations. Well, I have a special prize for you, a special present. It's math, your favorite. Yeah. Okay, anyway. Today what I'm going to go over is Module 5, Lesson 29, 30, and 31. That is the beginning of Topic F. Topic F is about adding and subtracting mixed numbers. So we're almost at the end of fractions. What we have left is we are going to add and subtract mixed fractions. Then we're going to multiply larger fractions and whole numbers. And then we're going to move on to decimals. Next week is the first week of April. Still waiting to hear something about when we come back to school, if we come back to school. We're still at that April 13th date. We're not getting any clear sign. I think they're still waiting. We're still waiting to see what happens. We're still waiting to see what the superintendent's going to say. What is the governor going to say? How many more cases are coming? How much longer do we have to, stay at home and stay out of the public as much as possible? So hang tight. Do your math. Do your science. Do your ELA. I haven't heard from Miss Moore. I don't know if she's going to add any extra material or not, but you should be reading. You should be looking at Miss Weiss's science videos. Her stuff is fun to look at. My stuff is a little bit harder because you got to think about it. And of course, Miss Chris, if you don't like reading, then you probably don't like reading and writing, but it's very, very important. I wish you all did like reading like I did when I was your age, and it helped me out so much. So maybe you need to find something that you like to read. Maybe it's a matter of going online. You can go online and download books from the public library, I'm pretty sure. Anyway, I just want to say happy birthday, Wa. Love you. If you have any other happy birthday shout outs you want me to celebrate, then just drop me a line, post something, guys. Feel free to talk on Google Classroom, talk to me on YouTube in the comment section, and let's get to our math. Okay, here we are back at the whiteboard. Today's whiteboard drawing is dedicated to an iguana this time around. Let's see, is that too dark? Let me brighten it up a little bit. Alright, that's much better. Okay, we're estimating the addition of mixed numbers and also subtraction. This is from Module 5, Lesson 29, and we're looking at two problem set problems from page 141. We're looking at 1D and 1E. This lesson is very, very easy. Remember, we're talking about estimating. And if you remember back when we did estimating, that this wavy line means to estimate, or it also means about how many, all right? The only thing you need to know is, what are you rounding to? What are you estimating to? What is the closest thing you're estimating to? So, in the directions for this, it says, estimate your answers to the nearest half or whole number. So I'm going to look down here at 1E first because it's the addition problem. It's the easiest one. Subtraction is a little bit harder. So let's look at the addition down here. It says 3 3/8 plus 5 1/9 is about How much? There's that estimation wavy line there. About how much? Okay, if I haven't mentioned it before, I'm sure I have, but if you don't remember, here are the steps when you are adding and subtracting mixed numbers. You can separate your whole numbers and your fractions and add them up all separately. Remember, this mixed number really means 3 plus 3/8. This one here is 5 plus 1/9. So it's really 3 plus 3/8 plus 5 plus 1/9. But remember, we're estimating, so you want to take each one of these mixed numbers separately and then add them together. We have a number line over here to help us with that. Now, if we're rounding to the nearest half, you need to know where that's at on the number line. And if we're rounding to the nearest whole number, you need to know where that's at as well. And we're using that benchmark 1/2 again. 1/2 benchmark. That means 1/2 is easy to find on a number line, and it helps you determine whether something is bigger or smaller than a half, closer to the whole number above it or closer to the whole number below it. So let's think about 3 3/8. Let me go over here to my number line, and I might have to do two separate number lines for both numbers. Let's think about 3 3/8. So I'm going to put 3, 4 whole numbers and 5 whole numbers. Okay, where is 3 3/8? And where is 1/2? Remember, it's closest to rounding to the nearest half or whole number. There are a few possibilities here. You can have a much different answer than I do by estimating, but we want to, it's got to make common sense. So here is 3 1/2 right here, right? And where are the eighths at? Well, the eighths, remember, can be divided this way. If I divide my halves up, I have fourths. If I divide my fourths up, I have eighths. Okay, I just created eighths. So let's see. 3, 3 1/8, 3 2/8, 3 3/8. So here is 3 3/8 right there. Let me get a red marker to show you where it's at. It is right here. Okay? Now, here's the question. Is 3 3/8 closer to 3 1/2, closer to 4, or is it closer to 3? Well, it's up to you. If you're thinking about the nearest whole number, it's on the left side of the half, so it would be closer to 3. Or, if you want to go to the nearest half, is closer to 3 1/2. So let's just say for now that it's closer to 3, the nearest whole number. 3 3/8 is closer to 3, so I have 3 plus. Alright, let's do our 5 1/9. So what I'll do here is, I'm going to make this a little bit longer. I'm going to extend that out. And I'm going to move this over a little bit. And we're going to call this 5 right here. And we'll call this 6. And we need our benchmark. Here's 5 1/2 in the middle. Okay. Now, where are ninths at? Ninths are different than our halves, quarters, and eighths. If we're talking about ninths, we're talking about 3 times 3 or 3 times thirds. So I'm going to create thirds like this. Here's 5 1/3, and here's 5 2. All right. In order to get ninths, I've got to divide those in half. No, I've got to put 3 hash marks in between each one. So there's 5 1/3, 5 2/3, 5 1/9, 5 2/9, 5 3/9. Here is 5 4/9, 5 5/9, 5 6/9, 7/9, 8/9, and then of course 5 9/9 is 6 whole numbers. So where is 1/9? 5 1/9 is right here. That's 5 1/9. Now, we can easily see that 5 1/9 is very close to 5. It's not even closer to 1/2. So what we're talking about here, this is so easy. If you're looking at these again, think about it as money. Is $3 3/8 closer to $4 or $3? No, it's closer to $3. If this was money, is 5 1/9, $5 and 1/9 closer to $5 or $6? If you only have one of those nights, it's closer to $5. So the answer, very simply, is 8. Now, if we were dealing with halves, the nearest half, I would have said 3 1/2, because 3 3/8 is closer to 3 1/2. And then, of course, this 5 is still closer, 5 1/9 is still closer to 5. So another answer could be 8 1/2. Alright, so we have two answers here. Either one is acceptable. Alright, now let's go up here and look at our subtraction. We have 6 1/8 and 2 1/2. We don't have to worry about subtracting our fractions here. And I'm not even going to use my number line. I don't need to. It's so simple. Because what is 6 1/8 closer to? Is it closer to 6 1/2 or 7? No. Only 1/8 more than 6 is definitely closer to 6. And what about 2 1/12? Is 1/12 closer to 2 or 3 or 2 1/2? No. 1/12 is very close to 2. Alright, so all we're talking about is 2 or 6 take away 2, or 2 minus 6 is equal to 4. That's really the only answer you should get here. 4 is your estimate here. And your answers for 1E could either be 8 or 8 1/2. I wouldn't spend a lot of time on this particular lesson. I would also look at the homework for the Eureka video and look at your homework and do that. It has some different ways of doing these, but again, these are estimates. This is getting it close to the nearest half or near a whole number. This should be very quick. This is a warm-up to a little bit harder work in in lesson 30 and lesson 31 coming up next. See you soon. Alright, we're back, and we're looking at Module 5, Lesson 30, page 145. This lesson is all about adding mixed numbers, only adding, no subtraction. And I'm going to show you a few things here from your problem set page 145. That's the first page of Lesson 30. Alright, the first thing we're going to look at is problem 1D, 1/8 plus 6 7/8. Now, let me get my purple marker. The thing to remember about these lessons, 30 and 31, is that we are thinking about what do we add, or what do we subtract, or what do we borrow from to make a whole number. So 1D is really simple. And you're going to see a new term called the arrow method. And I'm going to explain that in the Eureka videos. They also explain it. Arrow method is just another way of solving the problem or writing the problem down so it's a little bit easier to understand. Okay, so we have 1/8. Oh, and the other thing too, these are really simple because they all keep the denominator the same, so you don't have to find equivalent fractions. So let's look at 1D again. It says 1/8 plus 6 7/8. Remember, your mixed number can be written as a plus sign as well. This is 6 plus 7/8. So I can rewrite this. I can rearrange everything, and I can say 7/8. Remember, that's your commutative property. 7/8 plus 1/8 plus 6 is another way of looking at it. And if I add these two first, I end up with 8/8 plus 6. And what is 8/8? 8/8 is you've got the same number on the top as the same number on the bottom. That is equal to 1. One whole number. So 6 plus 1 equals 7. So simple. 6 7/8 plus 1/8 equals 7. Super duper easy, simple. Alright, let's look at the next problem. It's in the little boxes in the middle of the page. This is problem 2B. Now in this one, they left one blank in the addition, and you need to figure out how many more do you need to get to this whole number? So we have 7 2/5 plus what fraction equals 8? So let's think about it. Let me rewrite this as 7 plus 2/5 plus what, put that in parentheses, equals 8. And remember, what do we need? What do we need to get to 8? We're trying to make a whole number. What I was saying before. These lessons are going to ask you to find a whole number here. So, what do I need to make a whole number? Why do I need a whole number? Because 7 plus 1, and this is going to be the arrow method, we want 7 plus 1 equals 8. What do we need to get to 1? What do we add to 2/5 to get one whole number to make 8? Well, we got to get the top number or the numerator the same as the denominator 5. That would be 2 plus 3. So the answer is 3/5. Boom. 2/5 plus 3/5 equals one whole number. 1 plus 7 equals 8. I told you this stuff was easy. All right, now let me get a blue marker for the last problem. We have 3 3/5 plus 3/5 equals what? Now here's what I want to demonstrate what Eureka is doing. They want you to use decomposition. Remember, that's breaking apart. In this case, we're going to break 3/5 apart, and I'll explain why. And we want to break it apart in order to find a whole number to add to 3. And then whatever fraction we have left over, that's going to be put together to make a new mixed number. Okay, so what they're saying is they want you to break this apart. So I make this little decomposition bracket, or this is kind of like a number bond too. You can think of this as a number bond. What do I break 3/5 apart into in order to have one of these fractions add to 3/5 to make one whole number? Well, up here we said that 2/5 plus 3/5 equals 5/5 to make one whole number. We've got to do the same thing here. So I'm going to break this apart so I have 2/5. So I'm going to write 2/5. Let me try to make it a little neater. 2/5, and we need to figure out what is the remainder here. 3/5 minus 2/5 is 1/5. So we broke 3/5 apart into 2/5 and 1/5. Alright, and what they're saying is they want these two fractions to be added together to make one whole number. And now we're going to use what they're calling the arrow method. So we start with 3. Okay, and we said 2/5 plus 3/5, right? If I add these two together, I get 5/5. So the arrow is pointing us towards the answer, and it's just another way of making a note above it to tell us where we're going with this. 3 plus 5/5 is equal to 1, so that is 1 plus 3 equals 4. And what do we have left over? In fact, I'm going to eliminate this to show that we're talking about these two down here. What do we have left over? We have 1/5. Okay? This notation helps you keep it straight. Instead of doing it mentally, this is another way of putting it on paper to help you out. 3 plus one whole number plus 1/5 left over from decomposing 3/5 equals 4 1/5. That's all lesson 30 is doing. I would also look at the Eureka video. I would practice these and get this straight. Now you can also break this down to a number line. Let's do that quickly. I'm going to erase the one above it to give us room for a number line. Let me erase this problem in the middle, and we're going to look at this as a number line to help you out. So let me get a ruler. I'm going to keep using blue so you know we're still talking about the same problem. Alright. right? Let's make 3, 4, and then 5, because that's the range we're talking about here. So we started off with 3 3/5. So I got to break this up in fifths. Remember, 4 lines makes 5 parts. 1, 2, 3, 4. 1, 2, 3, 4. Those are your fifths. So we got a different color. 3 3/5 is 1/5, 2/5, 3/5. There's 3 3/5. And they want us to add 3/5 more, so I would count. See, let's put plus 3/5. Let's do our jump. 1, 2, 3. Here's where we land up right there. There's your answer right here. We end up with 4 and 1/5 by making 3/5 jumps. Now, you could use this method, or you can make your number line to find your answer. But either way, it makes sense. Whatever works for you to start off with. When you get really good at this, you won't need to do all this arrow work and everything. You can do this mentally. Figure out what your whole number is first. Add them up after you decompose this fraction. This step is going to be very important on the next lesson. When we subtract a fraction from a mixed number, we've got to make a whole number that we can subtract from. Or we've got to make a bigger fraction that we can subtract from. We're going to do that next on lesson 31. See you in a minute. Okay, I'm back. Forgive me for being wrong here, but the next lesson 31 is adding mixed numbers again, but lesson 30 was adding a mixed number to a fraction, and lesson 31 focuses on adding mixed numbers, 2 mixed numbers added together. And there's many ways of doing it, and it's up to you to pick the right way to do it. I'm going to show you a couple of different ways, and you should always arrive at the same answer. You'll also see, if you remember looking at the module book, that in lesson 30 they gave you an error analysis problem in the problem set, and they gave you 2 different ways of doing it. Jenny did it this way and Frank did it this way. They both got the same answer. You're supposed to explain why. After watching this might help you answer that, because there's 2 ways of doing this. Maybe 3, maybe 4 different ways of doing it. So let's start off. We're on page 152, the second page of lesson 31 problem set. We have 3b here. We have 1 3/4 plus 3 3/4. Now remember what I said before, is that mixed numbers are actually an addition problem. 1 plus 3/4 and 3 plus 3/4. One way of doing this is you can go ahead and add your whole numbers and then add your fractions. That's one way. So we have 1 plus 3 is 4, and 3/4 plus 3/4 is 6/4. Okay, if we're using this technique, we can go ahead, put a plus on here, and we can recognize that 6/4, let me put an arrow here, we can recognize that 6/4 is greater than a whole number, than 1, because the number on top is bigger than bottom. There's only one set of 4 in 6, and you have 2 left over. So this would actually be 4 plus 4 over 4 plus 2/4. This can be turned into 1. So we have 4 plus 1 is 5. 5 plus 2/4 equals 5 2/4. Alright, this is how I like to do it. I like to go ahead and add them, and then make this an improper fraction, then solve this for a mixed number, and then add those 2 together. That's one way. Here's another way they like to do it in Eureka, is they like for you to go ahead and add your whole numbers. 1 plus 3 is 4, but you're going to keep this 3/4 here. I'm sorry. Make this a 4 3/4. and then we have 3/4 left over. Alright? Then we can say, what do we add to 3/4 to give us a whole number to add to 4? Because remember, that's a plus sign there. You would do the number bond there. This would be 1/4 plus 2/4. Okay? Then you circle this, and we're saying 3/4 plus 1/4 equals one whole number. So that equals 5. I'm going to eliminate this and use this 2/4 and 5 2/4. Okay? So that is the second way of doing it. Of course, the third technique you could use is a number line. You can make a number line, but that is a lot of work to make a number line showing 1 3/4 and 3 3/4, and then showing how many places you jump. You would have to make a number line from at least 0 to 6 to do that and divide it into fourths. That's a lot of work. We need to go ahead and start simplifying these things a lot quicker. Alright, let's go down to the bottom and see if we can do that two different ways as well. Now, these numerators here are much bigger. We have 3 8/12 plus 2 7/12. Okay? Let's do this bottom technique first, the one that I like. We've got 3 plus 2 and 8/12 plus 7/12. 3 plus 2 is 5. 8/12 plus 7/12 is 15/12. Okay? Let me simplify again. I know that in 15/12 I can pull 12/12 out, and I know I have 3/12 left over. That's going to be 5 plus one whole number with 3/12. So 5 plus 1 is 6, and I have 3/12 left over. Alright? That is a quick way of doing it. Here is the super duper eureka way. They like to add 3 plus 2 is 5, and we leave the 8/12 there, and we're adding that to 7/12. We break 7/12 apart into fractions. We have two fractions. One, we add the 8/12 to make one whole number, and then whatever we have left over gets added to our answer. So if we break this apart, I know that I need 4 more 12s to add to 8/12 to make 12/12. So I'll put 4 12s, and 4 minus 7 gives us 3 12s over here. We circle this, so 4 12s plus 8 12s equals one whole number, plus 5 equals 6. We eliminate this, that's 6 3/12. So remember, that's 5 plus this, which is 1. 4 12s plus 8 12s is 1, plus 3 12s left over, and that is equal to 6 3/12. Okay? This is something, you can practice in lesson 31. Many ways of doing it. Many problems there to help you practice this technique. Also, check out the Eureka videos to help you out. Next thing I'm going to do is go to the Eureka book and do some of these with pen so you can see it better, and hopefully doing it on paper will help you in the long run understand this a lot better. See you soon. Goodbye. Okay, we're back in our module book. What I'd like to do is I'm going to combine 29, 30, and 31 just by working in the lesson 31 part of the book. So I am on the problem set, lesson 31, page 151. And I'm looking at number 2 here. I'm going to work with number 2 first because it does have that number line there for you already drawn out. Like I said, you can look at this as a number line problem as well. let's look at 2a. All right, 2a says 2 4/5 plus 1 2/5. So what did they do? They went ahead and added 2 plus 1 equals 3. They kept the 4/5 the same, and then they added 2/5 to it and combined it to show 3 plus 6/5. Then they did that thing where whenever you're making this number bond, you're trying to pull the whole number out. Here's the whole number right here, 5/5, and then we have 1/5 more. If we're using the arrow method, or the arrow way, you would show 3 plus 6/5, or you would say 3, then your arrow, 5/5, adding 5/5, and then you also have plus 1/5. That is going to equal 3 plus 1 whole number plus 1/5. That is equal to 4 1/5. All right. You can show the same answer this way as well. You can start off by making a number line. You can see the range is 2 plus 3 plus 6/5 more. So your number line should show that as well. I have 2, 3, 4, and 5ths. And since the denominator is in 5th, your number line has to be in 5ths as well. So let's show where 2 4/5 is. So there's 2, and 1, 2, 3, 4/5 is right here. So that is 2 4/5. Okay. I can make my 4 more like a 4. All right, and then we're adding 1 2/5. So how do I show one more here? How do I show 1 2/5? Well, what you want to do is you want to go ahead and make a jump in one whole number. One whole number is 5/5. So I'm going to go ahead and make a jump that's 5/5 bigger, or it's going to land up on 4/5 over here as well. So if I make a jump as one whole number, that's plus 1. I land up right here, which is 3 4/5. And then I have to make how many more? I've got to make 6/5 more. Alright, so let's do that. Wait, let's see if I did this right. We had 2 4/5, and then we're adding 1. Oh, I'm sorry, we're adding 1 and then 2 more fifths. See over here, that's 2 4/5 plus 1, and then I have 2/5. So let's make 2/5. 1, 2, that's plus 2/5. And we land up right here, and there's our answer, 4 1/5. Now I'm going to eliminate a lot of the steps, and I'm going to show you how quickly you should be able to do this. 3 8/12 plus 2 7/12. 3 plus 2 is 5. 8/12 plus 7/12 is what? 7 plus 8 is 15/12. Okay, now the way I did it is I'm showing a mixed number. You can turn that into an improper fraction, or you can pull this whole number out. 12 over 12. 12 minus 15 is 3/12. So that's 5 plus 1 is 6, and 3/12. That's how quick you should be with this. Okay? Alright, the next set of videos is going to focus just on lesson 32. Alright, 32 is subtraction of mixed numbers. We start off with mixed numbers minus a fraction. Then 33 is subtracting mixed numbers minus a mixed number. Lesson 34. This extra tutoring that I'm going to be doing, but I'm doing it for you guys. Your school year was interrupted. It was already a mixed up school year because we were so behind and we had so much testing, extra testing to do. I know it was frustrating for a lot of you. So I'm going to go ahead and do the extra work. Hopefully some of you guys out there will do the extra work with me and we'll enjoy our summer. So peace, take care, and of course, happy birthday, Wah. Happy birthday to you and your family. There's some gotcha life there for you, and I love you, Wah. I had a very good time this year teaching you, and if you guys have another shout out there for me to do for someone with a birthday, or if you just want to shout out for yourself, let me know. I'll say something nice about you. I can say something nice about every one of my 4th graders, no matter how much I yell at you, no matter how many times I had to write you up. I love all of you. Thank you. Take care.